Hello, this video is our intro to data displays. We will be spending about 2 weeks on this unit. We have two main learning targets for this video. First is I can classify categorical and numerical data, and the second is I can analyze categorical data in a display. So this is the slide we looked at in class. It says which digit shows up the most, the least, and is it close, and how can we know? Just take a second and look at this. See if you can come up with a way to figure out which digit shows up the most or the least. Chances are we would all come up with different answers to this, probably for some different reasons. So it's good for us to have some common language where we can talk about situations like this. So what is data? Data is simply information. So data can really be just about anything. There are two types of data that we work with. The first is categorical. So categorical data are words. So things that aren't numbers. So like heads or tails, boys or girls, things like that. Numerical is just what it sounds like. It's numbers. It can be whole numbers, it can have decimals, both work. We need to be able to organize the information, which is the data. The most common ways are listed below. So for categorical data, remember categorical would be words like boys or girls, or colors, green, blue, red, orange. First option is to use a circle graph. This is something I would think a lot of you probably remember seeing before, would be a circle graph. Another one we can use is a segmented bar graph. We'll look at an example of this one later in the video. For numerical data, we can use a stem and leaf plot, probably something you practiced in earlier math classes. You can also use a histogram or box and whisker plots. So this is one that I do want you to be familiar with, box and whisker plots. Depending on what math class you took last year, you may have seen these before, you maybe haven't. So make sure if you haven't or you want to review them, you take time and watch that review video and do a little bit of practice. So here's an example of a circle or pie graph. You can see this one is about sports. A circle graph is good for showing how pieces relate to the whole set of data. So here, for example, we can see that soccer is 30% of the entire graph, of the entire 100%. So we can easily see how the different sports compare to each other. This is an example of a segmented bar graph, similar to other bar graphs that you maybe have seen before, but you can see that we've literally stacked some different data on top of each other. So the red represents freshmen, orange is sophomores, yellow is juniors. I can see that in the key down there. And this is nice because we can compare the freshmen, sophomores, and juniors all in one graph instead of having three different graphs. So segmented bar graphs are really good for showing how the pieces relate to each other and to the whole. This is one we did in class. Just take 2 minutes to talk to a neighbor about which data display you think is better. So in this case, maybe in your head, just think which one you think is better or which one you prefer. So between a circle graph or a segmented bar graph, what do you think gives the most information or the least information? Okay, second part is about numerical data displays. A couple learning targets here. I can collect numerical data. Remember, numerical, we're thinking numbers. I can display numerical data in a stem and leaf plot, a histogram, and a box and whisker plot. And I can analyze numerical data in a display. Stem and leaf plot, like I mentioned earlier, you should be familiar with this from earlier math classes. The stem or the tens place in this example here is on the left side, and then the ones are on the right. It is good for showing repetition, spread, and the middle. So repetition, for example, I can see that 31, there's two ones there, so 31 shows up twice. I can see how the data spread out. So here the data goes from 24 to 67. I can see that easily. And I can also find the middle. Histogram is another one we can use for numerical data. Histograms are good for showing the middle and the spread. So if you remember on the y-axis, that's our y-axis, we have frequency, or how often something shows up. And then on this x-axis, we have length of words. So we can see how many times the different lengths of words show up in this Greek tragedy that we are talking about. We can also see the spread of the data, so I can see it goes from 4,000 to 11,000. I also can see that the data tends to be kind of clustered in here, with a lot of it being there, but we also have some data here and here. Box and whisker plots are our last display that we use really commonly for numerical data. We have some different pieces of information that you can see there. So the minimum at the end here is our smallest number. Maximum is the biggest, just like you would have found before. Median is the middle number, just like before when you'd found the median in other math classes. The two that might be new to you are Q1 and Q3. Q1 stands for quartile 1 and Q3 stands for quartile 3. So you can see they're in our graph here. So Q1 is the median or the middle of that first half. So Q1 is the middle of, it's a little off, but about that first half. And Q3 would be the median or the middle of this second part here. So it's good to show the spread and the median. When I look at this, at a box and whisker plot, I can really see how things are stretched or maybe not stretched. So we call the end pieces here, for those of you guys, this might be new, we call these end pieces here, those are our whiskers, and then we call this middle part the box. And box and whisker plots can look different. Sometimes one whisker is really long and the box is small. Sometimes it's really evenly balanced. And that tells you about the data. So if one whisker is really, really long, for example, we'll talk about that tomorrow, that's going to tell us how the data is skewed or whether the data is symmetric. So that is helpful to us as we are reading the data. So again, take a couple minutes just to think, what information do you think we can get from each of these, from the stem and leaf plot, histogram, and box and whisker plot? Which do you prefer? Which do you think is the most useful? Which gives us the least information? Things like that, because at times you'll have to decide which data display it is best to use, and it'll depend on the data that you're working with. At this point, make sure you have the homework for tonight. There was a worksheet, and if you have any questions, shoot me an email. Thanks.